Hello, our today's topic for AS level chemistry is the organic reactions mechanisms. Now, what is the reaction? Reactions mean breaking and formation of bonds. The breaking of bonds are of two types. One is called homolytic fission. Homo means same. Homolytic fission. And second is heterolytic fission. According to the definition, homolytic fission is the process in which shared electron pair is divided between bonded atoms equally. Bonded atoms equally. When bond is broken, then the shared electron pair is divided between bonded atoms equally. This is called as a homolytic fission. As a result of homolytic fission, in majority of the molecules we can use, the odd number of electrons are produced on atom without any charge. And the species which has odd number of electrons without charge are called free radicals. Now, free radical substitution reactions are the best example to explain homolytic fission. For example, for a simple case, if there are example of a hydrogen molecules. If we consider one molecule, the two hydrogen atoms are bonded with one another and they have shared two electrons between them and formulated a covalent bond between two hydrogen atoms. Now, if we apply energy to break this bond, as this bond is non-polar and same force of attraction from the both sides is applying on the shared electron pair. That's why in this molecule the electron charge density will be distributed equally between both of these two atoms. If we provide energy to break this bond, definitely as from both sides same force of attraction is applied. That's why whenever this bond will break, then one electron will goes to this hydrogen atom and one electron will goes to this hydrogen atom. Now, this is the equal distribution of electrons between bonded atoms. As a result, what will be produced? One hydrogen atom with one electron, this much, and second hydrogen atom with one electron is this. Now, these have odd number of electrons without any charge, so such species are called as free radicals. Such species are called free radicals, and this type of breaking of bond is called as a homolytic fission. Now, the curly arrows are indicated for the shifting of electrons. If one electron is shifted, then we use a half arrow sign which indicates that only one electron is moving from this point to this point or shifting. Only one-sided arrow is used for one electron, and if a pair of electrons shift, then we use a complete arrowhead which indicate that two electrons are going to shift. Now, as we are observing that from the pair of electron, one electron is shifting to this hydrogen and one electron is shifting to this hydrogen. That's why the bond breaking will take place at this point, producing two free radicals. Such type of breaking of bond is called as a homolytic fission. Now, in case of free radical substitution reaction, we know that there are three steps involved. Number one, first step is initiation. Initiation step mean this step start the chemical reaction. Second step is propagation step, and third is termination step. Now in this case also, this initiation step involves the production of free radical. Now free radicals are much more reactive than the molecules, so we use initiation step to initiate a chemical reaction. In case of reaction of chlorine with the halogens, we know that initiation step, chlorine molecule is provided a radiant energy, and in the presence of radiant energy, a covalent bond between two chlorine atoms will be broken down and producing two chlorine free radical. Now this electron on chlorine will indicate that this is a free radical. It has odd number of electrons in its last shell without any charge. So these free radicals will be utilized to start the chemical reaction between free radical, and in this manner the free radical substitution reaction takes place, which are the basic property of saturated hydrocarbons. Now the other type of bond breaking is called as a heterolytic fission. According to the definition, it is a process in which shared electron pair is shifted towards one bonded atoms, producing positive and negative ions. Here we can consider the example of HCl. We know that last shell of chlorine contains 7 electrons and 1 electron is shared with the hydrogen atom. But we know that chlorine is more electronegative as compared to hydrogen, and the shared pair of electron will spend more time around the chlorine side instead of hydrogen. This will create uneven distribution of electron charge density. As a result, what will happen? If the pair of electrons spend more time towards chlorine atom and spend very less time towards the hydrogen atom, automatically due to this uneven distribution of electrons, this more electronegative atom side will get partial negative charge and the other side will get equal magnitude of charge with opposite sign partial positive charge. Now if such bond is broken, if we provide energy, if such bond is broken, definitely due to the greater force of attraction from the more electronegative side, this pair of electron will tend to shift towards more electronegative atom, leaving behind the less electronegative atom. As a result, what we will get? We will get H positive and plus Cl negative. H positive and Cl negative. If the electron pair is shifted to one atom, then complete arrowhead will be utilized, indicating the shifting of pair of electron. In this manner, we get these positively charged and negatively charged ions. Now, this process of breaking bond is called as a heterolytic fission. Now, when heterolytic fission takes place, then categorically in an organic compound, whenever there is a difference of electronegativity between bonded atoms. Now, first of all, consider that this is the formula of methane. This is the formula of methane, CH4. the bond between carbon and hydrogen is considered to be non-polar because the electronegativity difference between both carbon and hydrogen atom is minimum. That's why the bond between carbon and hydrogen is considered to be non-polar. Whenever we break all these bonds, automatically homolytic fission will take place and hydrogen atom will produce with odd number of electron, and then after that those four free radicals of a hydrogen combine together to give two molecule of hydrogen. That's why in this case homolytic fission will take place. But if one of the hydrogen is replaced by the most electronegative atom, just like say chlorine, automatically the bond between carbon and chlorine becomes polar, due to more electronegative character of chlorine, due to uneven distribution of electron, this will get partial negative charge and this carbon will get partial positive charge. Now, whenever we will provide energy to break this bond, automatically the pair of electron will be shifted towards chlorine, producing a carbon with positively charged, and this is called as a carbocation. Now, this carbocation are of three types. If the carbon having a halogen is attached with only one carbon or with no carbon, then the halogenoalkane is called as primary halogenoalkane, and due to the heterolytic fission of bond, a primary carbocation is formed. But if the carbon having halogen is directly attached with two carbon atoms, then such type of the halogenoalkane is called as a secondary halogenoalkane, and due to the breaking of bond, a secondary carbocation will be produced that can be represented just like this. This is secondary carbocation produced. And if the carbon containing halogens is directly attached with three carbon atom or alkyl group, then this will be called as a tertiary halogenoalkanes, and heterolytic fission of bond will produce tertiary carbocation. Now, if we discuss the stability of tertiary carbocation is maximum, and then stability is of a secondary carbocation, and the primary carbocation is least stable one. Why it is so? Actually, all the alkyl groups have positive inductive effect, and they provide electrons to the positively charged carbon atom, due to which this positive charge on the carbon decreases most in case of tertiary carbocation, which reduce its reactivity and increase its stability. In case of primary carbocation, there is no alkyl group, or might be only one carbon group, one alkyl group may be in the primary carbocation. That's why the positive inductive effect of alkyl will remain minimum in case of primary carbocation. So this charge present on carbon is more prominent, which increase its reactivity and decrease its stability. In this manner, if we consider that all these positively charged carbon atom, carbocation, they will definitely attract the negatively charged electrons. That's why these are electron loving species. These are electron loving species, and electron loving species are called as electrophile, while those species which contain negative charge or lone pair on them and attract positive charge center, those are called as nucleophile. Nucleophile. For example, this NH3, due to the presence of lone pair or nitrogen, will act as a nucleophile. Similarly, water molecule, due to the presence of lone pair on oxygen atom, will act as a nucleophile. Similarly, OH, hydroxide, cyanide, all these can act as a nucleophile because they contain negative charge or lone pair, due to which they can attract positively charged centers or nucleus. That's why these species are called as a nucleophile. So there are two terms, electrophile or nucleophile. Electrophiles are those species which are electron loving, which have positive charge on them, or which are electron pair deficient. Then those will be act as a electrophile. And those species which contain negative charge or lone pair on with them, those will act as a nucleophile. I have explained all the concepts regarding this reaction mechanisms and some basic terminologies regarding whole of this process. I hope you have understood all these. Please like, share and comment and subscribe the YouTube channel for the upcoming videos. I thank you all.